Hi, welcome back. In this brief lecture, I want to discuss a very important concept in quantum computing. That is the lack or the absence of a copy instruction. So in quantum computing, we cannot really copy the values of one variable into another variable directly. So I want to dedicate one short lecture to it because of its importance. However, we will come back to this important topic later on in the following modules. So there is one operation that is typically available in all the classical computers, that is the assignment operations. For instance, we have a variable and then we can set it up to a certain value. So in quantum computing, we can do this only when we are preparing a state, when we are doing a write operation, and we have a non-classical state. So we can say this bit is in the state 1, for instance. So we can bring it to the classical state, assign the 0 state or the state number 1 to a certain classical register through the write operation. But what happens if we want to do the same with the quantum state? For instance, we have a superposition of state and we want to assign it to our quantum state. Well, this is not possible in quantum computing. So there is no way of copying some state partway through a quantum computation without determining what it is, so without making it a classical state. So this is a constraint coming from the quantum mechanics. So whenever we use quantum computing, we're using quantum mechanics, and quantum mechanics has a law that is called the non-cloning theorem that does not allow us to copy a certain, for instance, superposition quantum state into another state. So this is a constraint that arises from the fundamental laws of the physics governing quantum computing and our qubits. As I told you before, we discussed about the role reversibility or preserving the geometry. So all these are constraints coming from the fact that we rely on quantum mechanics law. So in the same way, in quantum mechanics, there is a fundamental law that is a non-cloning theorem that does not allow us to copy a certain value. However, we will learn later on how to make up for the lack of the copy in instruction, for instance, through swap operation or similar operation. I want to anticipate one of the topics that we're going to look at in the third module, that is quantum primitives, when we're going to look at the issue of the assignment operator, so the equal operator. So the equal operator is not available in quantum computing, and one of the fundamental reasons is that qubits cannot really be copied because the non-cloning theorem. So QPU can move qubits using exchange instruction. We will see later on through a swap operator, but QPU will never implement a copy instruction. So this is the topic of this lecture. As the results of this, the equal operator cannot be used in quantum computing to assign one qubit based value to another. If we have a quantum bit that is in a superposition, we cannot really copy its value because of fundamental non-linear theorem of the quantum mechanics. We will see later on that the only operation that we allow are somehow the update operation. So we have a value and we can actually update. So this is it for this brief lecture, and we will talk to you soon.